Okay guys, time to do a lift question. So, two elves, Archie and Beatrice, of masses 20 kg and 30 kg respectively, are inside the workship lift of mass 10 kg. Archie is riding piggyback on Beatrice as shown in figure 3. The elves are lowered to the ground using a rope which is attached to the top of the lift. The rope is modelled, okay. Given that the elves are moving vertically downwards with acceleration 0.8 meters per second squared, find the tension in the rope. Okay. So I'm actually going to redraw this just so we can get a better picture. So let's Archie is riding piggyback on Beatrice, so let's call Beatrice B and Archie can be A. Now in order to find the tension in the rope, which is going to be that, we're just going to label our forces here. So the mass of the lift is 10 kilograms, therefore its weight is 10 times gravity. The mass of Beatrice is 30 kilograms, so her weight is 30 times gravity. The mass of Archie is 20 kilograms, so his mass is 20 times gravity. Now I'm just going to quickly redraw because it's going to get crowded otherwise. Really at this stage we don't need to consider anything else, and I'm going to show you why we don't need to consider anything else. Now, because these are connected particles and they're all traveling in the same plane in the same direction, that's still going to be 10g. This means that we can consider the system as a whole, i.e. all particles and all forces acting on these particles. Now, the forces acting on particle B, I'm not going to draw its weight, otherwise it's going to get too crowded. I'm just going to draw the normal reaction force acting on B provided by the lift. So let's call this P. Now, by Newton's third law, B then exerts an equal and opposite force onto the lift. So we'll also call this P. Then B exerts a normal reaction force onto A. So we'll call this R. And A exerts an equal and opposite force onto B, which is also R. Like I said, there is still also the weight of A, which is 20 times gravity, and the weight of B, but I'm not going to draw that on for now. What I'm trying to, and also it's worth mentioning that there's no support force acting on the lift, i.e. nothing is pushing up on the lift because there's no surface, because obviously the lift is in the air. So what I'm trying to show is that when we consider the system as a whole, these forces are going to cancel out. So we've said it's accelerating downwards. A equals 0.8. And that means there's a resultant force downwards. So if we consider all forces going downwards, that's going to be 10g plus P plus R minus all forces going upwards, P plus R and then plus T, equals the mass of everything, since we've considered everything. So that's going to be 60 times acceleration, which we know is 0.8. Now what I'm trying to show here is 10g plus P plus R minus P minus R minus T. These just cancel out. So we're left with 10g minus T, which is why we can stick with this diagram for now. So the tension in the rope is, we started it here, 10g minus T, and then using F equals ma equals 60 times 0.8. Rearranging for T, we get that this is 60g because we've considered the weight of all particles. So 60g minus T, my fault, equals 60 times 0.8, and therefore T equals, I'll just quickly do that on my calculator now. T equals 540 newtons. So we've answered part A. Now let me just quickly rub this out. Okay. So, to find the magnitude of the force that Beatrice exerts on Archie, we're interested in R. And this force right here. Now the problem is, we have to consider the forces acting on A in order to find this. So the forces acting on A is the weight of A, which is going to be 20g, i.e. 20 times gravity. And the force that B exerts on A as it pushes up, which is R. And that's it. Now the reason I say that we have to consider the forces acting on A and not the forces acting on B, remember it's acting on as well, by the way, not just all the forces which are apparent. So all the forces acting on B are going to be its weight, which is, it's 30g. And then the force that the lift pushes up onto B, which is P. But it also has R. And because of these two unknowns, we can't do anything at the moment, which is why we have to consider the forces acting on A. So let's get rid of this. Now, forces acting on A, which is also accelerating downwards, just like Beatrice, just like the lift, everything is accelerating downwards with acceleration 0.8. So let's calculate the resultant force. That's going to be 20g minus R. Using F equals ma, that equals 20 times 0.8. Rearranging for R, that gives us 20 times 9.8 minus 20 times 0.8, and so R equals 180 newtons. Now, the normal reaction between Archie and the floor of the lift is just P, and so if we get our diagram back up of the forces acting on B, in fact I can just change this, I can edit this slightly. So this is the forces acting on B now. We've got the weight of B, which is 30 times gravity. The force the lift exerts on B, which is P. The force A exerts on B, which is R, which we can actually substitute to be 180 newtons, as we just worked out. And that's it. So now, again, B is accelerating downwards with 0.8 meters per second squared. So to find the resultant force, we're just going to do all the sum of the downwards forces minus the sum of the upwards force, and that equals mass times 0.8, i.e. mass times acceleration. Rearranging for P, that gives us 30 times 9.8 plus 180 minus 30 times 0.8, which is 450 newtons. And that's it.